Today's presentation is about man's struggle against infections, sulfonamides. In the early 20th century, there were medicines available for certain dreaded diseases like syphilis. Then also there was treatment for protozoal infections, and the compound that was being used, one example is selverson. These compounds were actually the derivatives of arsenic. The concept was that arsenic is a poison. It is a cumulative poison. Along with that, you attach some organic moiety so that it will kill the infectious organism. It is Paul Ehrlich who is considered as the father of chemotherapy. Chemotherapy is the usage of chemical agents to cure diseases caused due to infections. It was Paul Ehrlich who propounded the concept of a magic bullet. A magic bullet is one which will be selectively toxic to the invading organism and will cause the least damage to the host. That means it should be selective in its action. With that concept, all over the world, people were working because there was no treatment for streptococcal and staphylococcal infections, because of which many people were dying. There is no treatment at all. So all over the world, people were looking for agents, and in that they started synthesizing dyes, organic dyes which are used in textile industry, and dyes are synthesized in chemical industries. And they thought of dyes because of two reasons. One is it is easy to synthesize dyes by a process called as diazotization. That is, any compound which has got an NH2 group, it can react with another compound containing nitrogen, and diazotization. Di means two nitrogens will come together. There will be a bond of N double bond N, and these are colored compounds. Dye compounds. Usually, those who have studied chemistry at PUC level, they would have synthesized dyes in a test tube. That is one of the tests. So, because of the easy access to synthesize dyes, and one more thought at that time was that these dyes would be selectively active against microorganisms. With that thought, they started synthesizing, and so many dyes were being screened. And one particular dye by name Prontosil was found to be effective in infected mice with staphylococcal infection. With severe infection, mice could be cured and their lives could be saved. And this was at the laboratory level. Then actually, they would they thought of doing the in vitro studies. That means testing the compound on the bacterial cultures. That is, if you do it in a petri dish, you look for the zone of inhibition. Nothing was there with Prontosil, but it was curing in vivo. That means it had effect in vivo. Then people started using Prontosil itself in severe infections caused due to streptococcal and staphylococcal infections. And you see, one can imagine the desperation that was there at that time, because you had to save the lives. Without having any proof to the effect that it is effective in vitro, people started using it, and so many lives were being saved. And Gerhard Domack, a German physician by profession, his daughter fell sick due to streptococcal infection, and he saved her life by administering Prontosil. And later on, he was, for his pioneering work, he was given Nobel Prize, and Gestapo prevented him from receiving the Nobel Prize. And in 1947, he received his Nobel Prize in Stockholm. So this is the background. Now, sulfonylamide was being used. This Prontosil was being used without any proof to the effect that it is active at the laboratory level in vitro. Then they started looking at the people who were being treated with sulfonylamide. Then they found out that in the urine of these people who were using Prontosil, they isolated sulfonylamide. Sulfonylamide is Benzene ring, see, even though my presentation is meant for common people, but some amount of chemistry is required, otherwise it's not possible at all to say anything. So benzene is a hexagonal ring structure. At every corner there is CH. In that one hydrogen, if you remove and put NH2, that becomes aniline. Then 1 2 3 4, at the fourth position, if you write SO2 NH2, that is sulfonylamide. That is the compound which they found out is the actual drug which is having the antibacterial activity. So here what happened was, they isolated sulfonylamide and then they tested that for in vitro studies, and it had antibacterial activity. So the actual drug is sulfonylamide. So with this, two concepts were proven. One is chemotherapy, that means you can use a chemical agent to kill any infective organism. Second one is prodrug. Prodrug is what? Prontocell is the prodrug. That means it is not a drug, but it will release drug in vivo in the system. So with that, then hundreds of sulfonamides were synthesized all over the world, and only about a dozen of them are useful, were found to be useful. I should use the word were, because not all of them are useful today because of the advent of penicillin and other effective antibiotics, and not only that, because of the indiscriminate use of sulfonamides and the associated toxicity of sulfonamides. Now, sulfonamide structure is there. Then what happened in the usual developmental process is that once you get the lead molecule, you have to make structural changes on that to look for so many, because you have to have so many other weapons in your armament. Variety should be there. You just cannot have one. So like that, so many compounds were synthesized. But one toxicity that was there, along with the sensitivity towards sulfonamide, one toxicity that was there was crystal urea. That means sulfonamide, while being excreted through the urine, it was not being excreted because it was not soluble in the urine. That means crystal urea was the problem, but still people continued using it because there was no other choice. What is that? They had to choose between living and having this particular problem of sulfonamide. Then they found out that sulfonamide was not soluble in urine because of the pH. The pH of the urine is around 6. So what could be done? You had asked people to drink more water. Actually, it will dissolve. That was what was suggested. Or administration of urinary alkalizers. That means make it alkaline. Administer urinary alkalizers so that the pH will go up and it will dissolve and come out. Or triple sulfase. That means at that time so many sulfonamide derivatives were available. Here the derivatives are prepared in such a manner that the anilino nitrogen, that is at position number 1, NH2, which is there, it is left unsubstituted. That SO2 NH2 is there. Now that hydrogen is substituted by various groups. So like that you have different sulfonamides. And triple sulfa, if you use, what happens is the solubility is an individual characteristic of each compound. So the solubility will be different, but the total amount of sulfonamide that is administered will remain the same. So this also is one approach wherein you can use mixed sulfas for reducing the formation of crystal urea. But then later on they thought the best thing would be to synthesize such sulfonamides which will be soluble in urine. Like that you have so many sulfonamides. Now what is the mechanism of action of sulfonamides? The mechanism of action is this. Now we are talking this as an antibacterial agent. That means some organism has come into our system that will naturally be in our blood. So you have to use something to kill that microorganism, and that concept of selective toxicity, magic bullet, it should cause no injury to the host, but it should finish the invading organism. That should be killed, that should be finished. For that you have to know how it lives. All these bacteria, they have their own cycle. One cyclic mechanism is there wherein they synthesize their folic acid. Actually directly they synthesize dihydrofolic acid. They have a de novo synthesis for dihydrofolic acid, but we don't synthesize, being such big human beings, we don't synthesize our folic acid or dihydrofolic acid. We directly get it from the diet. We directly get it from the diet, and the microorganisms cannot use the folic acid that is available in tons for them in our body. They synthesize their own folic acid. Directly they synthesize dihydrofolic acid. Dihydrofolic acid is next converted to tetrahydrofolic acid. It is mediated through an enzyme called dihydrofolate reductase enzyme. That means dihydrofolic acid is reduced. It is called as dihydrofolate reductase enzyme. Then tetrahydrofolate or tetrahydrofolic acid, which is synthesized, is converted further to the coenzymes of folic acid. These are all essential for the microorganism to sustain for its growth and for normal living. So if you can hit at this is what it eats. That's all. This is the only thing on which the microorganism lives. So what could be done? They looked at the synthesis, the pathway that is there for the synthesis, for the de novo synthesis of dihydrofolic acid. What it does is it prepares its own para-amino benzoic acid. Sulfonamide also is para-amino benzene sulfonamide. Para-amino benzoic acid is para-amino benzene carboxylic acid. Para-amino benzene carboxylic acid. It is called as PABA. Para-amino benzoic acid is used by the microorganisms to directly get the dihydrofolate. Now sulfonamide, because of its structural similarity, it is also para-amino benzene sulfonamide. In place of COH, there is SO2NH2. So this is picked up in place of para-amino benzoic acid, and it curtails or inhibits the synthesis of dihydrofolic acid. So that is how you are stopping the growth of the bacteria. Next step is whatever dihydrofolic acid is there, it is directly reduced next to the tetrahydrofolic acid using that enzyme dihydrofolate reductase enzyme. It is also called as tetrahydrofolate synthetase also. Now here the selectivity comes into picture. The enzyme that is used by human beings for bringing in the reduction is structurally different from that of the bacteria, and we are lucky there. And you can have one compound here which can inhibit the enzyme of the bacteria, and that is achieved by a compound called trimethoprim. So if you can use a combination of these two, that is competitive inhibitor of para-amino benzoic acid, you can use a sulfonamide, and the dihydrofolate reductase enzyme inhibitor trimethoprim. If you use the combination of these two, you have effective control, or you are almost killing the bacteria. It will have a bactericidal effect. And actually this combination was in use, and several pharmaceutical companies made their fortunes using this, and the brand names are Septron and Bactrim. These are the two names I am able to recall. It is a combination of trimethoprim and sulfamethoxazole. Sulfamethoxazole trimethoprim combination was used. Bactrim and Septron were written by all doctors, and people started taking it, and benefit was there. And ultimately, what happens is the organism grows resistance. How will the organism grow resistance? I had said that even though tons of folic acid is available by the diet from which we use, it is not able to use that capacity is not there. So what it could do is it can increase the synthesis of para-amino benzoic acid to fight sulfonamide, or it can directly start using the folate coenzymes which are there in our system. So this is how the microorganisms grow resistance. Okay, that is why it is always a struggle only. If there is resistance, then you have to find out another way of tackling this infection. So this is so far as the mechanism of action is concerned. What I am trying to say here is when there is infection. Now, for example, COVID was there all over the world. You know how people died. Similar situation was there when sulfonamide was introduced. But COVID is totally different. It's a viral infection. It is very difficult to treat. Antiviral agents effective. You have to find out. See, they took decades and centuries before they could find out all these drugs. And this concept also came only in the early 20th century. So after having known this, okay, even though there is some chemistry and all, in general now I feel a common man should be able to understand that when there is an infection, there is a disease, and that can be treated by using a chemical agent like sulfonamide. That was the first one to be used. That is why I am talking about that first. Now when you look at the structure of sulfonamide, NH2 benzene ring, SO2 NH2. Now these sulfonamides are actually useful agents even today. For example, sulfostamide eye drops are useful. They are whenever you get conjunctivitis or any problem with the eye, first thing to be prescribed is sulfostamide eye drops. So sulfonamides can be grouped based on their usage also. So one is for ophthalmic preparations, then for reduction of bowel flora and ulcerative colitis. That means ulcer and colitis pain, if it is there, for that also sulfas are there, even today they are used. And here I can quote the examples of two of them, sulfasalazine and thallyl sulfathiazole. Sulfasalazine and thallyl sulfathiazole. Here what happens is that NH2, which is attached to the benzene ring, that also is substituted. That is the only difference between this agents which are used for reducing bowel flora and for rather treating the intestinal infections. The major difference is the NH2 that is directly attached to the benzene ring is substituted. Why? So that it is not absorbed. All other sulfonamides are absorbed and get into the bloodstream, and they show their antibacterial activity in the blood. That is where the organism will be there. Now, when you have to treat something in the stomach or in the intestine, you have to use an agent which is not absorbed. In order to prevent that absorption, this group is attached to the NH2 of the benzene ring. And these are effective so that they are locally active. So there are two types of compounds I said. One is for eye infection, optically useful for ophthalmic purposes, then for treatment of infection in our digestive system. And there is another third type. These are the sulfas which are used for burn therapy. If there is a burn, it takes a long time. What happens is when there is burn, our system, everything gets baked. It is very good nutrient for all microorganisms. It gets cooked. The flesh gets cooked, so it is difficult to treat. So usually there are two compounds that are used. One is mephinide, then the other one is silver sulfadiazine. Silver sulfadiazine. That means the silver salt of sulfadiazine as a solution is used and poured all over the body. Similarly, mephinide also is used. And mephinide, structure-wise, there is a difference for those people who are interested in that. Sulfonamides are NH2, benzene ring, SO2, NH2. In case of mephinide, it is between NH2 and benzene ring, there is one CH2. So in the strictest terms of sulfonamides, it is not a sulfonylamide. One CH2 will be there. So three types of compounds you can have based on their usage. Otherwise, there is one more type of classification based on their duration of action. There is one particular class of compounds, short, well absorbed. Okay, that is the difference. These are well absorbed, short and intermediate acting sulfonamides. Here the compounds are sulfamethizole. The compounds are sulfamethizole, sulfisoxazole, sulfacetamide, sulfachlorpyridazine, sulfapyridine, sulfamethoxazole, sulfadiazine. So sulfur remains the same based on the heterocyclic ring that is attached, different, that is diazine, pyridazine, pyrimidine, okay, isoxazole, sulfisoxazole, sulfamethoxazole, all these things are there. These are short and intermediate acting sulfonamides. Then another class is well absorbed and long acting. There are only two compounds. One is sulfamerazine. The other one is sulfameter. These are very rarely used because of the known toxicity of sulfonamides. So with this, we have understood the first chapter in the arena of chemotherapy. It was clearly established that chemical agents could be used or can be used for treating infectious diseases. Only limiting factor is that it should not be toxic and that selectivity should be there. It should be selectively toxic to the invading organism, causing least damage to the host. In spite of the chemistry that is there, at least one point is clear for the general public, that if there is an infection and we cannot see the infecting organism, it can be treated. And how it is treated, for that they have studied the mechanism of its living. Okay, what is the biosynthetic pathway for it, which makes the survival of the microorganism. If you know the biosynthetic pathway for the synthesis of folic acid and its coenzymes, then you can strike at the right place and see that the microorganism is killed. This is the concept of chemotherapy. Namaste.